Okay, for this problem, tartaric acid, which is H2C4H4O6, has 2 acidic hydrogens. The acid is often present in wine and precipitates from solution as the wine ages. A solution containing an unknown concentration of the acid is titrated with sodium hydroxide. It requires 24.65 milliliters of 0.3 molar sodium hydroxide solution to titrate both acidic protons in 55 milliliters of the tartaric acid solution. Calculate the molarity of the tartaric acid solution. Okay, so this is a titration equation, and so the first thing we want to do is start with the balanced chemical equation. So even though we're not entirely certain, it tells us in the problem there are 2 acidic hydrogens, which are these first 2. So we have H2C4H4O6, okay, plus NaOH is going to form. So we know that we're going to get a salt and a water, and so these 2 acidic protons are going to mix with hydroxide to make H2O, okay? And then we're going to add to that, so the sodiums are going to interact with this. When it loses these 2 protons, they'll be replaced by sodium atoms. Okay, so we know that there's going to be 2 sodiums here. Now that balances here. These 2 acidic protons mix with these 2, and we get 2 moles of water. Okay, so now we have a balanced chemical equation. So now we can use the information in our problem to try to solve that balanced chemical equation. So in this case, we know how many milliliters interact with how many moles, and so we can determine the moles of hydroxide that are used in this balanced chemical equation. So we'll start with 0.3 moles per 1 liter of sodium hydroxide. We're going to multiply that by the volume that we used in liters, 0.02465 liters, which gives us 0.007395 moles of NaOH. Now, the trick here is to use our balanced chemical equation to convert the moles of sodium hydroxide into moles of tartaric acid. Okay, so our 0.007395 moles of sodium hydroxide, NaOH, times our balanced chemical equation, stoichiometric numbers. There are 2 moles of NaOH for every 1 mole of H2C4H4O6. Okay, in this case, there are 0.0036975 moles of tartaric acid. Okay, so now it asks for the molarity. The question is, how do we do that if we have the moles? Well, it turns out it tells us the volume of the tartaric acid solution, and so we know that there are this many moles in this many liters or in this many milliliters, and we can determine the molarity. So if there are 0.0036975 moles in 55 milliliters, which is 0.055 liters, we can solve that to be 0.067227 molar. Now, we should probably take into account our significant figures, and so if we look back in the problem, all of these values have 4 sig figs. So this has probably 1 too many, so it'll be 0.06723 molar tartaric acid.